Good morning, my YouTube viewers. Crystal here. I just wanted to make you another video this morning. The video that I wanted to make you was how I scored 100% accuracy on Kaggle's breast cancer data set. And so basically that's what I'm going to be talking about in this video. Now, on my last video, I talked about sklearn's breast cancer data set, but sklearn's data set has a lot of limitations on it. And the reason why it has a lot of limitations on it is because the one, it looks like something's been done to it, but even if something wasn't done to it, it doesn't have the columns labeled. It doesn't say what's benign or malignant or anything like that. So the Kaggle breast cancer data set is superior to the sklearn's breast cancer data set. This is the information that we get from Kaggle's breast cancer data set. It's a lot more informative than the information we got from the sklearn's breast cancer data set, even though in theory they're supposed to be the same data set because they both came from the UCI. That's University of California, and I stands for the city that it's in, though I don't remember the city that it's in. So I'm just going to read you what it says about the breast cancer data set in the Kaggle website. It says features are computed from a digitized image of a fine needle aspirate of a breast mass. They describe characteristics of the cell nuclei present in the image in the three-dimensional space that is described in K.P. Bennett and O.L. Mangasarian robust linear programming discrimination of two linearly inseparable sets, optimization methods, and software 1, 1992. This database is also available through the UWCS FTP server, FTP, FTP, CS, WISC, EDU, CD, Math, Prog, CPO dataset, Machine Learn, WDBC, and the WD means Wisconsin. The W means Wisconsin. I don't know what the D means, and the BC means breast cancer. And they give you attribute information. ID number, diagnosis, M is for malignant, B is for benign. 10 real value features are computed for each cell nucleus. A, radius, mean of the distances from center to points in the perimeter. B is texture, standard deviation of grayscale values, perimeter, area, smoothness, local variation in radius, length, compactness, perimeter area, concavity, severity of concave portions of the contour, concave points, number of concave portions of the contour, symmetry, fractal dimension, coastline approximation. The mean, standard error, and worst or largest mean of the three largest values. These features were computed for each image, resulting in 30 features. For instance, field 3 is mean radius, field 13 is radius SE, field 23 is worst radius. All feature values are recorded with 4 significant digits. Missing attributes values, none. Class distribution, 357 benign, 212 malignant. And then they give you the website for, and it says, and I put that in there. I told you the website. So basically, if you want to use the Kaggle data set, then you've got the website so you can use it. And what I did was I wrote this program in Google Colab and saved it onto a GitHub repository. but unfortunately my GitHub repository wasn't loading up, so I'm viewing it on NB Viewer. So if ever you have a situation where your GitHub repository doesn't load up, you can view it on NB Viewer, which is what I'm doing. The thing about creating your programs on Google Colab is the fact that it's got Python and the libraries already installed on it. But one thing that I recently found out is that Google Colab does not install the most current versions of the libraries. So if you're having a problem with a particular library, you need to check to see which version of the library you're using. Now I know that Google Colab does not use the most current version of sklearn, and sklearn is one library that I tend to use a lot of, but you can install the most current version of sklearn on Google Colab if you want to, but I just didn't want to. I just decided I would just make do with what I had. And so after I created my program, I imported my libraries of NumPy, Pandas, Matplotlib, and Seaborn. NumPy is a library that allows you to carry out algebraic functions. Panda is a library that allows you to work on the data frame, and Pandas is written on the back of NumPy. Matplotlib is a library that allows you to do graphics and visualizations, and Seaborn is another library that allows you to do graphics and visualizations, and it's written on the back of Matplotlib. So after I imported my libraries, what I wanted to do was I wanted to load my data set. So what I had done was I downloaded the Wisconsin breast cancer data set, and I downloaded it, and then I saved it into a GitHub repository. But the thing is if you decide to use Kaggle's data set, then you will need to download it and save it somewhere. So I save as many things as I can in my GitHub repository, and the reason why is because I don't want to use the memory on my computer as I do most work online. I have a Google account, and I'm only allowed to have like 15 gig of data, so I want to keep as little data as I can on my Gmail account. And the reason why is because I've got lots of programs on Gmail already, and at some point I'm going to have to go through and delete some of the programs when I run out of memory. After I imported the libraries, I loaded the data set, and you can see this is your data set here. And you have one unnamed column, column 32, which is just not a number. So what I did was I dropped that column from the data set. Data equals data drop, unnamed 32, axis equals 1 data. And so if you go through it, you see that there's no more number 32. Now we check data info. You can see all of the columns except for one were numeric. The column that said diagnosis is an object column, which the reason why is because it doesn't say 1 or 0, it says V or M. Now what we wanted to do is we wanted to check for missing values, and in this instance we didn't have any missing values, so we didn't have anything that we needed to impute. And so now what we're going to do is we're going to do a little bit of an analysis. So we did SNS displot data diagnosis, and you can see that you had more benign tumors than you had malignant tumors. What we did was we used value counts to determine how many we had of benign and malignant. You'll see that we had 357 were benign and 212 were malignant. Then I wanted to see what the percentage was. So I divided the value counts over the length of the data set to get the percentage. So you had 62.74% were benign and 37.26% were malignant. Next thing I did a heat map so you can see how the different columns correlate with each other. And I will say that last night when I was at the food share, I was looking on the internet to try to get code for winning values and the thing winning programs. And the thing is people who win a competition are not going to give you their code because it's like a trade secret. So number one, they're not going to give you the code for winning the competition. And number two, it's probably just a really haphazard mesh of little pieces of code here, there, and everywhere. And so you're never going to see it. You will get code, like I'm posting code on the internet, but I've never won a competition. So I post the code that I can give you to the best of my ability. And one of the reasons why is because I couldn't win a Kaggle competition even if I wanted to, because I believe you have to be in the United States to win a competition. And a lot of these people who are entering competitions, they're really superb programmers, which I'm not a superb programmer. And so I give you as much code as I can. But one thing I did find out yesterday when I was looking up code was the fact that someone had written about this heat map. So you make a heat map and you take away all of the columns that are less than 0.4. So all of the columns that are less than 0.4, you can remove those columns, and those columns will help to improve your accuracy because they're not contributing anything meaningful. So it was a little bit difficult. It was a little bit difficult for me to do, but I did remove a few columns. I just removed as many columns as I needed to remove until I got 100% accuracy. And when I got 100% accuracy, I stopped moving columns. But this person that wrote the article, he wrote it on another program. He said that he removed all columns that were less than 0.4% correlation. So basically anything in the black or purple range, you can remove those columns and it might improve your accuracy. So I tried that last night and then I found out that yes, it did in fact improve my accuracy. So we'll go along. Next thing I did was I created a 2D diagram for you using this bit of code for the 2D diagram. And so how you can see how the benign and malignant points are mixed into the computer's memory. So ideally, the benign and malignant points would be completely separate. And when they were completely separate, then it would be very easy to predict on them. But because you've got like the benign and the malignant mixed together, it's actually more difficult to carry out a prediction because the model's got to try to figure out which one is benign and which one is malignant. The next thing we wanted to do is we want to define our X and our Y value. So Y is data diagnosis and X is data drop, diagnosis, ID, smoothness SE, and compactness SE. And so, as soon as I got my 100% accuracy, I stopped I stopped deleting files, but I guess deleting columns. But I guess a person, if they were really into it, they could have deleted all the columns that were less than 0.4. But I didn't do that. I just wanted to get the highest accuracy as possible, And when I got my 100%, I stopped. So you can see your X with 1, 2, 3, 4 columns deleted. And then we check our Y. So Y is going to be either M or B. Y doesn't really affect the prediction, but it will affect the 2D graph that I'm going to make. And you can see here on the 2D graph here that you got M and B, and it didn't affect the prediction at all, but it will towards the end when I make the other 2D graph, it will affect it. So what I did was I ordinal encoded the Y. So rather than using sklearn's ordinal encoder, because you don't know what value sklearn is going to give to the B and M, I decided that I was going to map it, because at least when I map it, then I can determine myself what value I want B and what value I want M. So I decided B would be 0 and M would be 1. Then I normalize it. And when you normalize it, what you're doing is you're taking it to a value of between 0 and 1. And then I split the X data frame up, or the X array up, into training and validation sets. And then I define my model. And in this situation, I just went into the sklearn to see which classifiers they had that I had never used before. And I decided I'd use the Gaussian process classifier because I'd never used that before, and I wanted to see what it did. So I used it, and I got a 99% accuracy when I trained and fitted on the trained data. And when I predicted on the validation set, I got 100% accuracy, which is what I wanted. I wanted 100% accuracy. I created a confusion matrix, and when I created the confusion matrix, you can see that we had 34 and 0.0 and 23 and 1, and those are correct. And then I created a data frame so you could look at the predictions and compare them against the actual values. And the next thing I did was I wanted to graph the errors. And when I graphed the errors, that is why I had to ordinal encode the target, because I don't think it was going to accept strings. It was not going to accept letters. So because it wouldn't accept letters, I had to actually convert the letters to numbers. And so you can see that since I had 100% accuracy, there's not any yellow dots on this diagram. So the purple dots are the correct predictions, and the yellow dots would be the incorrect predictions, but it was all correct. So that's good. So now what we've done is this code review, and we've gone through the code of this data set. We've used a completely new model, and we used a new technique of deleting the columns that have a low correlation. So that concludes this video. I hope you got some information out of it to help you score 100%, and who knows, you might win a competition sometime. So thank you very much for watching this video. If you want to keep receiving videos from me, then please like, subscribe, and share. And if you want to be notified whenever I make a new video, then on the press the bell button next to the subscribe button, and you will be notified whenever I make a new video. If you like the work I do and you want to support me, then I've got my email address to my PayPal account in the description box below. And the reason why that is because I don't have enough subscribers. Once I get enough subscribers, I won't need to ask for donations. because I'll be able to monetize. So again, thank you so much for watching this video. I look forward to making more videos for you in the future.